Have you ever thought to yourself, how much am I actually spending and saving each month? Although these financial questions can feel very uncomfortable, but as the cost of living continues to rise, having these difficult conversations are crucial for us to live a sustainable lifestyle. Just as budgeting helps us understand our financial wellness, it turns out that this very same accounting mindset can also help us conceptualize the hidden costs of what we pay for our food through modern agriculture. Every year, billions of dollars are spent on fertilizer use for crop production. However, only a fraction of that fertilizer input ultimately ends up in the harvested crops, just between 30 to 50%. Imagine asking an investor to accept losing half of every dollar they invest. That is a very difficult pitch, but for decades, this has been the reality of the food system we rely on. This raises an important question. If plants can take up less than half of the nutrient input we apply, where does the rest of its nutrition come from? And that answer lies just right beneath our feet, the soil. Most people think of soil simply as dirt on the ground, but it is way much more valuable than that. In fact, soil functions more like a bank, storing away nutrients and energy in the forms of soil organic matter, where plants and microbes can utilize them for growth and maintenance. One way to think about soil organic matter is like our checking and savings account. These accounts hold on to carbon and nitrogen in the soil, which carry the resources vital for plant growth. Particular organic matter, or POM, acts like a checking account because it primarily consists of partially decayed plant material and organic residues, providing quick sources of food for plants and microbes. On the other hand, mineral-associated organic matter, or MALM, serves as a long-term savings account, storing away carbon and nitrogen for decades to come by binding them to reactive clay mineral surfaces. But soils cannot move these resources into savings on their own. That job belongs to the soil microbes, the bankers of the soils. They take fresh plant materials from the checking account, process them through their enzymes, and deposit them into the mineral savings account. With the right working environment, these microbial bankers become more efficient at forming and cycling organic matter. This is where my research kicks in. I study the accounting of carbon and nutrients in the form of soil organic matter, specifically to identify what is the optimal condition for microbes to maximize their work efficiencies and savings. Leveraging the right microbes in the right environment to manage soil organic matter is the foundational first step towards increasing fertilizer use efficiency, while also removing carbon emission from the atmosphere. From an accounting mindset, I believe the more we can understand and budget the dynamics of these soil organic matter accounts, the more prepared we are in making sustainable agriculture a reality. Thank you.